Welcome to EDU World Space.
In this problem, we have a mansard roof truss that's loaded as shown. We have 1.2 kilonewton loads distributed along the top here at each one of the joints. And we're asked to determine the forces in member DF, this one, DG, this one, and EG, this one. So what we can do is we can cut this right here, and so then when we cut it here, we then expose the forces in these three members. First thing we need to do, though, is figure out what these reaction forces are, and because of symmetry, we know that they're the same on both sides, and so the reaction force is on each side is 3 kilonewtons. So that's what this is and this is. And so when we cut this, now we expose these three extra forces, FD to F, FD to G, and FE to G. And now if we do force and moment balances, so our in the X direction we have FDF plus FEG and plus the X component of FDG, which is 4/5 FDG. And in the Y direction we have R, and then we have minus 2F, and then minus the Y component of FDG, which is 3/2 FDG. And then we can take moments about whatever point we'd like, and I picked point D here, which is this point here, because that gets rid of this, this, and this. And so we take moments about this point, and this distance here was 4 meters. So we have 4 times F, it's a positive moment from this force. The moment arm is this length here, which is 6.25 meters, so we get minus 6.25 times R. And then this distance here is 3 meters, so we get minus 3 FEG. So then we then get, let's see here, we have, that would be a plus. This is this way, yep. And so now we have 3 equations and 3 unknowns, and we can just start substituting. The easiest one to do is get this one, and that's 4.65 kilonewtons. FDF is minus 5.45 kilonewtons, and FDG is 1 kilonewton. So what we see here is the angle one has the lowest load. This one up here is in compression, and this one is in tension. And that's what we would expect, because we'd expect this to be bending like this. So the ones above the center line here should be in compression, and the ones below will be in tension.